Hi guys and welcome. In this video we're going to go through what's called a 5-problem group task. However, you won't be in a group, but so if you haven't already, you can download the PDF and print it off. It's in your Schoology folder for today. Or if you'd prefer, you can just do it in a notebook. I would suggest if you're not writing things on a PDF or on an actual worksheet format that you do everything in the same notebook for this class. So in the event that if I were to test you or quiz you on it, you've got it right there. So I would title this 5-problem group task. There's a quiz after it on Schoology as well, and you can use your notes, so no reason not to ace it. I'm going to head on in here and get my iPad hooked up. I'm just looking at my hair, looks kind of funny. How are you guys? It's getting kind of boring, isn't it? And it's just starting. Oh, and I see I've got some gray roots up here too. Oh, well, what you gonna do, right? That's what happens when you're in your 50s. Ah! No, I'm just having fun. All right, so I'm going to be just as goofy in this video as I normally am in class. So here we go. I'm going to log into my iPad, get that screen to share for you. And again, we're doing 5-problem group task, and we can just do it together. So here we are. I think I'll hide myself up here if I can find it. Let's do, no, didn't want that. Let's do stop. All right, now I'm gone off of there. So let's begin. So this is on Taylor polynomials. By the way, for the AP test, they have come out with what they're not going to be testing on this year. And you'll be hearing a lot about the format if I haven't already told you about that. I'm not quite sure when we'll get the go-ahead to deliver the full format. We know that the date of the AP test is still intact. We just don't know what day it will be, but they're definitely going to do it. On April 3rd, I believe, is when they're going to release what the date or dates will be if we're eligible for a later date. I also know that there won't be any multiple choice questions, but I also am pretty sure that it won't be traditional free response either. And that's all I can say. I know it's not multiple choice. I know you'll be doing it at home. I also know that they've cut out some content due to a lot of teachers not being able to go back to school. Unfortunately, the big unit they cut out was polar parametric, which we spent so much time on and you guys were so good at, so that makes me kind of sad, but there's a lot more going on than polar parametric functions right now, so I guess I'll just have to get over it. Also, they cut out some stuff in series, but this Taylor polynomial stuff is not something that got cut out. So we're going to make sure you have a really good understanding of this because I'm 100% sure you will be tested on this concept. So let's begin, and there'll be a quiz on this in Schoology when you're done, and you can use these notes. So let's go. So for number one, I think what I want to do first of all here is revisit what just the standard form of a Taylor polynomial is. We say that some function f of x can be approximated by a Taylor polynomial of nth degree. And you'll be told where to center it. So for example, when we talked about the sine wave, we said, well, let's center that at 0. And let's fit a curve to that sine wave to use to approximate what happens. So in that scenario, f of x would have been sine of x. And my polynomial of nth degree depends on the degree. This is a 5th degree up here, so it would have maybe looked like that of some sort. I don't know. Anyway, remember what we do is we evaluate the function at its center. So whatever the center is, in this case, we're going to use 0, which means it's also called a Maclaurin. Then we do the first derivative, evaluated at the center, times x minus the center over 1 factorial, plus f double prime, evaluated at the center, times x minus the center squared over 2 factorial, plus f triple prime, evaluated at the center, times x minus c to the 3rd over 3 factorial, plus And then we end it with whatever degree we're supposed to, evaluated it at the center, x minus c to the nth, over n factorial. So for this one up here, we've got the 5th degree. What that means is the constant in the 1st degree got wiped out. Must have had a 0 in there somehow. So it says find the 4th derivative evaluated at 0. Well, the 4th derivative goes with the 4th degree term. So here's what we do know. If we were to write that one out a little bit more, we'd have in specifically for ours, right? When we're writing that polynomial, it would have been f of 0, must have been 0 because it's not there, plus f prime at 0 times x minus 0 over 1 factorial, must also have been 0 because it's not there, plus f double prime at 0 times x minus 0 squared over 2, plus f triple prime. Again, I'm just replacing my c up here with a 0. F triple prime evaluated at 0 times x minus 0 cubed over 3 factorial. And then lastly, plus the 4th derivative evaluated at 0, which is consequently is what I'm being asked to find, times x minus 0 to the 4th over 4 factorial. This right here is 4x squared. So this must have been 0, this must have been 0, but really what I'm concerned about is this term right here, because it's 3x to the 4th, which means this 3 right here, the positive 3, must be what the 4th derivative of 0 over 4 factorial equaled, because it's the coefficient of the x to the 4th term. So we're going to take that coefficient of the x to the 4th term in the model and set it equal to the coefficient that it ended up being in the polynomial expansion. What that means is the 4th derivative can be found by just doing 3 times 4 factorial, which would be 3 times 24, which is 72. All right, so that's it. Pretty straightforward. A lot of kids, if that's multiple choice, would circle 3. So you got to make sure, like, for example, this 7 would be set equal to, it's the coefficient of the 5th degree term, which would be the 5th derivative evaluated at 0, x to the 5th over 5 factorial. So the 7, I'm going to put the x to the 5th, and then I'm going to cross it off. The 7 had to be equal to that. So to get the 5th derivative, we'd multiply 7 by 5 factorial. The next one's a little tricky because we have to be careful with our signs, but our SIG and S's. We are writing a 3rd degree Taylor polynomial to approximate f of x. So I'm going to say f of x can be approximated by a 3rd degree Taylor polynomial. This couldn't be called Maclaurin because it's centered at 1, which is found by, and again, I'm just going to write it out. I like every time you do these, you should write it out just to get it in your head. F of c plus f prime of c times x minus c to the 1st over 1 factorial plus f double prime evaluated at c times x minus c to the 2nd over 2 factorial plus f triple prime evaluated at the center times x minus c cubed. You might say, why aren't you putting in a 1 for c? I'm going to. I just like to write that out every single time. What does that equal? It's going to equal f of 1. Why 1? Because the center's 1, kids. And then it's going to equal plus f prime of 1 times x minus 1 plus f double prime evaluated at 1 over 2, because 2 factorial is 2, times x minus 1 squared, and then plus f triple prime evaluated at 1 over 3 factorial, which is 6, times x minus 1 cubed. All right, so what do I need to get this to work so that I actually have a viable 3rd degree Taylor polynomial? I need to find f prime, f of 1, f prime of 1, f double prime of 1, and f triple prime of 1, and insert them in. So I go off to the side, and I'm going to write down what f of x is. F of x is the natural log of 4 minus x, which means f evaluated at the center is the natural log of 3, and that will be my lead term on my Taylor polynomial expansion. So there's the first one. Next, what do I need? I need to figure out what's the first derivative so I can evaluate it at 1. So f prime of x is u prime over u, and at 1, f prime of 1 would be negative 1 over 4 minus 1, so a negative 1/3. So this right here is a negative 1/3. Negative 1/3 times x minus 1 to the first. Next up, I need to find f double prime at 1. Well, f prime was negative 1, I should put equals there for linkage, 4 minus x to the negative first. Sorry, it's getting messy. I don't have a whole lot of room to write on here. F double prime of x will equal, chain rule, I'll bring the negative 1 out front, it'll cancel off the negative, I'll get 4 minus x to the negative second times a negative 1. So, again, when I put in a 1 to this, I'm going to get a negative from this. 4 minus 1 is 3, so I'll get a 3 to the negative second, or a negative 1/9. That's what's going to go in for f double prime. So I have a negative 1/9 of 1 times x, negative 1/9 of 1. Actually, that's not wrong, but negative 1/9 times x minus 1 squared over 2. Again, this is getting really messy because I'm running out of room, but hopefully you get the process. So my next and last thing I need is f triple prime of x, so I can stick in a 1. Well, again, the negative 2 is going to come out front to become a positive 2. 4 minus x to the negative third, correct? But then times a negative 1 with that chain rule, or negative 2 over 4 minus x cubed. And when x is a 1, that would be negative 2/27. So plus negative 2/27. Again, that's my f triple prime evaluated at 1. X minus 1 cubed over 6. Now this right here can be left if it's an FRQ, and you're not going to have multiple choice. So I'm not even going to talk about that anymore, I guess. Right? All right, so the next one piggybacks off an old question. So all this, by the way, interesting enough, all the easy part of your series test will also be on the AP exam. I'll explain more of that later, but they won't have like the alternating, what don't they have? I'll have to look and tell you, but the harder parts, like I don't think I saw the integral test on there. I think that got cut out. The easier stuff like P-series, geometric, that all retained itself, but they cut out kind of the harder stuff, which was good for you guys because you were great at the easy stuff. So let's talk about a positive, whatever, integer, not interview. For what positive integer value of k, remember integers are your 0, 1, 2, 3, 4, and negatives, will both of these converge? Well, you have to identify what kind of a series it is. Geometric in my face only converges, right, if the ratio, k thirds, is less than 1 in absolute value, correct? So keep that in mind. I need k over 3 to be less than 1. Over here, my negative 1 to the kn, and it says positive integer value as well. So basically, when we have the positive integers, it's just 1, 2, 3, 4, 5. So actually, since I started with this geometric, right there, I know it has to be either 1 or 2. Right? So 1 or 2, since I started with the geometric, to get that ratio to be less than 1. Now, for my alternating series, if k was 2, then I'd have negative 1 to the second to the n, which is just 1 over n, B divergent harmonic. I need to make sure that I actually have that negative 1 in there. So I'm going to need to use a 1. Oh, dang it, a 1 for the k. So only 1 works here, so I'd have negative 1 to the nth over n, right, which is the alternating divergent harmonic, which converges. All right, and then I've got my my geometric series, which was 1 or 2, so the common answer would be 1. This one you have to be really careful with because it says sequence. And remember, sequence is a list. All it needs to have is a limit. For example, if the limit's 9, I'm going to be writing comma 9, comma 9, comma 9, comma 9. I mean, it won't actually be 9, but it'll be converging to 9, like comma 8.9, 8.99, 8.9999. So we take the limits, and if we have one, the sequence diverges. Remember, sequences are different than series. So you might say, oh, the nth term test for divergence. For a series, you're right. The limit as n approaches infinity of, let's call that a sub n, is equal to 3/2. And if that had been a series, then I just keep adding that 3/2 and I'd say, well, it diverges. But I'm going to be listing that. So this right here actually converges when it is in sequence notation. The next one, the e to the n over n, you could L'Hopital that if you want. As n approaches infinity, it's infinity over infinity, but when we L'Hopital that, we definitely, and we know the top's going to take over. So this guy does diverge. The sequence, the limit of the rule of sequence is infinity. The limit of this guy as n approaches infinity is also 1, which does not mean we diverge by the nth term test, because this is a sequence, which means this is what's going to be happening, not this. All right, so the answer would be just e to the n over n. And lastly, and the most important one, this is how I anticipate you're going to be asked it on the AP test. So let's go deal with this guy right here. What is the value of cosine 2 using the 4th degree, not 4 terms, but 4th degree Maclaurin, that means my center's at 0, expansion for cosine? That's one that you need to memorize. Cosine is an odd function, even function, sorry. It can be approximated by, and if you remember, we always do, I'm going to write this down, my Maclaurin polynomial of degree 4. Remember, it always starts with f evaluated at the center, and my f of x in this scenario is cosine. Cosine 0 is 1, so that might help you. This starts at a 1. It's actually 1x to the 0 minus, and then we go evens, 2 factorial, plus x to the 4th over 4 factorial, and then truncate it because it said to stop at the 4th degree. So it says, what is the value of cosine 2? Well, cosine 2 would be approximately 1 minus 2 squared, which is 4, over 2 factorial, plus 2 to the 4th, which is 16, over 4 factorial, which is 24. Divide those each by an 8, and it looks like we have a 2/3. All right, so I'm getting a -1 plus 2/3, or a -1/3, which equals -0.3 repeated. That's what my guess is using my Taylor polynomial of 4th degree. Now keep in mind, again, graphically, it's really nice to understand what's going on here. The cosine wave goes like this, right? And we are centered right here. F of 0 equals 1. We didn't do a tangent line approximation. We're wrapping this with, as best we can, a 4th degree Taylor polynomial. Now, I don't know. Remember, they agree at the center, and then after that, there's some error. But what we're guessing is that the cosine of 2, let's go to cosine of 2 radians, remember on your unit circle what 2, I'm going to go over here. Oh, dang it. So this is pi over 2, or about 1.5 radians. 2 radians is sort of over here, and we can see the cosine is negative and that it's past pi over 2. So we're going to be about down here, which we can see that that's got a negative y value where y equals cosine x. And on my Taylor polynomial, the red one, I'm saying -1/3. What is it exactly on my calculator is a good question. If I actually go to the calculator and do cosine of 2, give me a minute to go do that. Cosine of 2 on my calculator comes out to be -0.416. And then some more stuff, 1/4, whatever. Notice they're off. What that means is there's a little bit of separation between the red and the yellow right here. But How about the maximum error? This is an alternating series, which means our maximum error is bound by the absolute value of the first unused term in the sequence, which would be negative x to the 6th over 6 factorial. So it would be negative or positive now, because we're going to do the absolute value, 2 to the 6th over 6 factorial, which on a calculator comes out to be 0.08 repeated. And I challenge you to check that our approximation is actually within 0.08 repeated of the actual. You subtract these, you'll be less than 0.08888. So that's it. Next up is you should go take a little Schoology quiz on these notes, but you can feel free to use them. It is time. All right, have a good one, guys. Bye. Miss ya. I miss you. I'm getting bored at home.